All right, now, so let's have a little fun with that first reaction here. So the HCl with water to give us hydronium and chloride. And here's the question that we're going to ask ourselves. Let's think about, so looking at this reaction as it's written, what species results in the loss of proton from the Bronsted-Lowry acid? So as we discussed a few slides ago, the Bronsted-Lowry acid in this reaction, as it's written, is the HCl. Now, when you take the proton away from HCl, you are left with chloride. Now, let's look at the reaction in the reverse direction and ask ourselves, is that species, the chloride, acting as a Bronsted-Lowry acid or a base? So if you look at this, the chloride ends up as HCl, looking at it backwards, so it clearly picked up a proton. So that species is acting as a base. Now, let's go back in the forward direction and look at what ends up from the original Bronsted-Lowry base after it takes up that proton. And that species is kind of a process of elimination, the other product, the hydronium. And now again, let's look at the behavior of that species in the reverse direction. And is the H3O plus acting as a Bronsted-Lowry acid or a base in this, and it's acting as an acid. So what became of the acid is acting as a base, and what became of the original base now is acting as an acid. So the behavior seems to flip. Now, go ahead and play that same game with all four of them and see what we come up with. And so I'm just going to go ahead and do one more as an example. So again, this was originally a base, this was originally the acid. What becomes of the acid after it's given off the proton? Well, it becomes hydroxide. And in the reverse reaction, that's acting as a base. The original base, ammonia, picks up a proton, becomes ammonium, but in the reverse direction, that's acting as an acid. And what you should be able to convince yourself is that this is the same thing for all of them. That the species that the acid becomes after it gives up its proton acts as a base, and vice versa. The species that ends up as the base after it takes the proton, that new species, acts as an acid. And these have a name, and they are called conjugate acid-base pairs. So these are species related by the gain or loss of a proton. So for example, HCl and chloride are a pair in this reaction, as are water and hydronium. And for the last one, actually, let me do this one just to give you a different conjugate for water. So the two pairs here would be NH3 ammonia and ammonium, NH4 plus, as well as water and the hydroxide ion. And this is a thing, so the behavior flips after the proton transfer.